This is recording.
RTI
International
Center for
Forensic
Science
presents
Just Science.
Welcome to Just Science, a podcast for forensic science professionals and anyone who is interested in learning more about how real crime laboratories work. In episode 7 of the 2019 R&D season, Just Science interviews Dr. Audris Mockus, a professor in the Tickle College of Engineering at the University of Tennessee, Knoxville, about an image cloud platform for use in tagging and research on decomposition database. Over the last few decades, researchers at the University of Tennessee Knoxville Forensic Anthropology Center have been photographing and cataloging the decomposition of the subjects in their body farm. With the help from Dr. Audris Mockus, they're turning this collection into an image database for both research and forensic investigation. Listen in as Dr. Mockus discusses the database and its potential impact on both post-mortem interval estimation and our understanding of human decomposition. If you are interested in emerging drug topics, please visit forensiccoe.org to learn more about the upcoming NIJ Policy and Practice Forum on July 18th and 19th in Washington, D.C. This season is funded by the National Institute of Justice's Forensic Technology Center of Excellence. Here's your host, Dr. John Morgan.
Welcome to Just Science, the podcast for forensic science professionals. I'm your host, John Morgan, with the Forensic Technology Center of Excellence, operated by RTI International and funded by the National Institute of Justice. FTCOE provides technology transition resources. Please check out our resources at www.forensiccoe.org. And we cover just about every forensic science discipline for professionals like yourself or just interested people who want to learn more about where the research is heading in the field. Today's guest is Dr. Audris Mockus, who has a PhD from Carnegie Mellon and is the Erickson Harlan D. Mills Chair and Professor in the Department of Electrical Engineering and Computer Science at the University of Tennessee. His latest interests concern models of the open source software ecosystem based on version control data, which is not what we're going to be talking about today. But he also has an interest in anthropological phenomena hidden in large image collections, which we are going to be talking about today. He's interested in recovering information and creating models of reality from big operational data. He's worked at Avaya Research, AT&T, and Lucent Labs. Welcome to the podcast, Audris.
Thank you.
So you're with the University of Tennessee, and obviously Tennessee has the very notable body farm there. And the body farm has actually gotten to be quite extensive over the years, and that's created a big data problem, hasn't it?
Yeah, so I was actually been here for a year or so until I sort of realized there's this interesting collection. I was told by my former advisor of that. I was working on sort of large image collections before, and he said, look, I mean, this is a fantastic opportunity for you to take a look into that. So this particular collection has over 1 million images collected over about 70 years by now. And images are taken, daily of every subject, and every day you have about 40 different photos. They're taken by hand. They're not particularly easy to sort of analyze computers, but their purpose wasn't really originally to do that. The purpose was to document the decomposition process because, once it's over, it's over. You can't go back and see what happened without any sort of documentation.
Yeah, and it's becoming an even bigger problem just because the level of donations to the University of Tennessee Body Farm is quite substantial. And so I think I heard the figure that, they're getting over 100 donations a year now. So they are going to have, like you're saying, 40 active, at least, bodies in decomposition on the site. And that's an incredible trove of information for the research community more broadly to be able to take advantage of.
That's right. So there's already over 500 subjects there in the photos, and it's going to be growing faster. To be frank, there are other body farms, in different weather conditions around the country, around the world, and they're all trying to, follow the lead of Anthropological Research Facility, which is the name of this particular facility, also taking photos as well. So the challenge is really not just this facility, but also more generally.
We actually just did a post-mortem interval workshop at American Academy of Forensic Science. And although there's an enormous amount of scientific work that's done, there's not enough work that's been done relating multiple mechanisms by which you can estimate PMI. And therefore, you can have a lot of disconnect among different approaches. Having a data set that cuts across all of the different remains and conditions that you can do the kind of analysis that your work enables, I think is an extraordinary advance and very, very important.
So my original vision was something of the following, is that you have, say, crime or just any sort of law enforcement situation where you have a potential crime scene, say, and you have some photo of that crime scene, right? So one of the first things is, reconstruct how things got to the point they are when the potential crime scene was observed. Maybe body was found somewhere in the forest or some other place. My sort of vision is that, you take a photo of that crime scene, then you basically take that photo and match it against all the possible decay scenarios that we have in this anthropological research. And you basically say, here's a bunch of these that match the most closely. And you can look at them and sort of get some idea about possible, PMIs that could be there, simply based on very simple input.
Well, that's really interesting. In other words, there are obviously a lot of environmental variables that can affect a particular PMI and a particular body that's decomposing, as well as, pre-mortem experience with the body that can happen. And so by being able to take a particular crime scene case and by doing a match of the photo database that you're working with, as well as have tagged and have the ability to access, you can actually match up those variables against what might be in a particular case to be able to do a more accurate PMI estimation.
Exactly. So one example would be that you could match not just the photo, but you could also match the weather conditions, which we also keep track of and associate with every image in the database as well. If you get the historic weather information for a specific location and the crime scene, you could search for that in the database as well as the images itself. Now, I should say that the purpose of exposing content of the images is a little bit more general than just doing a PMI estimation, simply because, as I was told, again, I'm not the big forensic scientist, but as anthropologists here say, there's not very good understanding on how certain things happen, in particular things like mummification and other things that could be observed on the corpses that, sometimes they happen under certain conditions, sometimes they happen under very different conditions. And understanding exactly when certain features are prevalent is very important. And therefore, the primary purpose of this attempt is to essentially do three things. First is to take this million images and allow people at least go and browse them. Right now, it's very sort of difficult even to find what you need, even if you know what you need. To allow them to basically say, here's separation by subjects, here's separation by some demographic factors, here's separation maybe by seasons, and so forth. Second part involves actually something a little bit more. It says, there's certain things that forensic people want to see, whether it be researchers or law enforcement, they want to find. They have certain types of forensic features that they are looking for example, in crime scene and elsewhere. And they want to find images that correspond to these features. Now, these features, unfortunately, like one of them I mentioned, mummification, there could be maggots, there could be other features. So first step we did, we created a nomenclature that sort of defined what common terms are used in human decomposition. And then we developed a system whereby a postdoc or graduate researcher would go in and create tags, essentially mark the parts of these images with a specific feature from that nomenclature. And so that way, over 2 years, we have created 2,000 images with about 5,000 these distinct features to start the collection.
There are several different paths, of course, that a corpse can take. The mummification is certainly one of them. It can be skeletonized. You can have, if it's in water, you're going to have a different set of changes as well. You have pre and post bloat and things of that nature. And so being able to actually examine very specifically how that works is very useful. I love this idea of nomenclature because I do believe that is nomenclature and standards are where science begins, and being able to have an accepted nomenclature is extraordinarily valuable. Let's take a step back a little bit just to make sure folks know. So this is called the Cloud Platform for Use in Tagging and Research on Decomposition, ICPUTRD. I see Putrid, I guess. I don't know whether that's deliberate or not, and it's been funded by NIJ. You had an initial NIJ grant, and you've just started a second grant as well. So can you kind of lay out, too, because not only do we want to give credit to NIJ, but we want to kind of give people a feel for kind of where you're sitting, kind of where the initial grant began and ended, and then what you're expecting to do under the new grant.
So I sort of described more or less the content of the initial grant. So the idea of initial grant was to organize this collection, allow access to that collection, develop the nomenclature of the human decomposition terms, and manually mark images containing these. And that's kind of been completed. We also did a user study just to validate that what we did works well. We actually not quite finished. We're going to do another user study this summer. We did a user study with researchers, but we want to do a user study with law enforcement officials. Basically, user study asks 3 questions. First question is, can people use the system? So we give them specific terms from nomenclature and ask them, can you find images with these tags? Second question is basically a question about the completeness of nomenclature. We say, well, now go ahead and search for whatever you care about, whatever images you are interested in. Then we look at what people typed in to see if perhaps they invent some new terms that we don't have in the nomenclature. And the third part of the user study was essentially a consistency, or what's called cross-rater reliability. Do people mark these forensic features in the same way? If we have 10 people and we ask them to annotate, tag the same image, how similar their tags will. And for the most part, that's been a success. So that's kind of the grant that's over.
The third element in particular is of some interest, because, of course, that's been an issue within a broader range of forensic disciplines, and that is, for example, does a latent print examiner approach a crime scene print the same way as another examiner? Do they determine whether they go into an APHIS search or of high enough quality for an APHIS search in the same way? And that kind of consistency and cross-rater reliability is an interesting general issue within forensic science. Are the law enforcement people who you're going to be working with in the summer user study, are they people who are actually going to be applying this kind of thing in practice already? So you'll have some people who are practitioners that you're examining in the summer?
So yeah, the hope is that these are the people who come here to take courses, related to the body farm. And so some will be from FBI, some from local law enforcement. So the hope is that these would be actually real practitioners.
And of course, you're not studying them per se, but you're really looking at the usability of the database. But it is of some interest with respect to how consistent they would be and how they approach the images.
Exactly. I think this kind of brings back to the next grant. So what we have is over 2 years, got like 5,000 tags. We have 2,000 images tagged, and it takes quite a bit of effort to do these tagging. Like one image to tag, takes maybe 20 minutes. If it's a complicated image, could take even longer. So if we have 2,000 images tagged, we've got 998,000 images that are still untagged, right? So to do that, through pure manual tagging is certainly out of question. So what we're trying to do is right now developing machine learning techniques that learn from these existing tags that are already made and try to sort of tag automatically the remaining images. So we have the full collection more or less tagged. And so there's, of course, a lot of difficult challenges lying around, and I can mention just some of them. Additional machine learning techniques, they expect very cleanly annotated images where every feature is marked. And, if you have 1 million maggots on an image, you really can't mark every maggot. That all the features are tagged. It's not feasible. We really need to cover a lot more images. If we wanted to do that, we could do like maybe 1 or 2 images in a half a year. So we can't do that. And it requires a lot of examples for each class, that is for each specific type of nomenclature. And we have about 100 terms. So really what we need to do is we're really kind of beyond what the traditional, what sort of state of the art in machine learning is. We need to deal with these challenges. And so that's what we're trying to address with the second grant, is come up with a way to have this kind of human in the loop or expert in the loop tagging system that sort of you produce certain tags and then the system sort of produces some predictions. It gives them back to you, and then you see either agree with them or you disagree with them or you correct it. That way the system sort of learns as fast as possible and requires minimal number of tags in order to achieve high accuracy. So that's one of the goals. The second goal we want to achieve, and I forgot to mention, is to some extent we achieve, but we need to experiment with it, is collaborative nature. So if you have 2 or 3 researchers tagging images, it would be nice if they could share that information together. And we sort of tested that a little bit with this cross-rater reliability in the tagging. But it would be interesting to kind of allow people to have like kinds of tag gifts. One is like curators, which use these official tags that we somehow trust them, and then allow any researcher to create any tags they want. But then if they feel comfortable, they can share them with others, let others verify them. But if they're not, they keep them to themselves. So images are the same, but the tags could come from multiple individuals. And then we have this kind of collaborative approach where we allow more than one team to really go ahead and do the tagging, and that way sort of increase the productivity as well. So we're kind of looking at 2 ways. One is automating this process, and another way is involving other researchers and law enforcement officials as well. If they use the system, that they would actually also produce their own tags, and we have some mechanism of quality control so we can incorporate them into an overall set of tags.
So I'm going back to kind of your overall research interests with respect to open source software and dealing with big operational data and image data and that kind of thing. This is a perfect data set for somebody with your research interests. Can you tell me, is there a comparable community out there that is doing something similar to this? I mean, is there a model that you're working off of, or kind of what is this building off of more broadly, technically, from beyond the forensic science realm in terms of how image analysis is done and sharing, kind of a community practice in terms of how images might be analyzed?
Right, so that's a very good point. Yeah, so my background is really, as you mentioned in the beginning, I spent a lot of times, 25 years, analyzing software development, in particular open source software development. Now, open source software development is a particular community that's centered around specific data, which is the source code, that they sort of reuse from others and contribute back to the community, and others build on it. So it's been immensely successful. Nobody believed it 20 years ago. Now, everybody relies on it. So it turns out you can make lots of money on that. So 20 years ago, 30 years ago, there was a lot of backlash about that, especially from Microsoft, but now Microsoft is big embracer of that as well. So I'm sort of modeling a little bit based on that, is how much you can do if you share your knowledge with others and build on sort of validated knowledge. So there's, of course, challenges there, right? So how can you trust that this code, this component that you're going to use is going to work for you? And there's various ways that could be done in trying to do that and trying to build on the knowledge from there. So that's kind of one thing that inspired this collaboration, at least aspect. Another example is, in general, in science, is that a lot of science really grows based on really common shared databases. And I think if we could construct something like that for forensic community, and especially, specifically for human decomposition, but maybe in other areas as well, I think that could spur a lot more research, because now people really have large data sets on which to try their approaches, easy to validate which approach works. You can do competitions. It's been tremendously successful. So I'm also kind of using that example from machine learning community, where they share the text databases, where they share the image databases, as well, and trying to sort of apply some of that aspects here as well.
Well, that's fascinating. So how is it that folks from outside of the University of Tennessee can be a part of this community that you're building, either as researchers or practitioners?
That's an excellent question. So one of the first things that I realized is forensic science is quite different from open source software development.
There's a very big deal, with not just forensic science, but in law enforcement in general, about trust. Do I trust this source of information? Do I trust this individual? Do I trust this colleague in another agency? It really does sometimes stand in the way of our ability to get the most value out of the information that we have.
So I totally respect that. I think there's good reasons for that. I think another challenge to this, and again, these are my desires, another challenge that I talked with a number of people who run these body farms is that the data they produce is their kind of crown jewel. They want to really control the access to that data as possible. So to answer your question, yes, just write to the director of our research center, and Donnie Stedman, and she will, arrange for you to have access, do research either on premises, or hopefully, by next year we will have online access set up so that you can actually, do have this access remotely as well. So yes, it is a challenge, and I understand the reason for that challenge, but I do think we need to move in the right direction from this perspective. And right now, I think the way to proceed is we want to see more use cases, real use cases, both of research and practical forensic investigation that are using this data set, because that will allow to build a better system that anyone could use elsewhere. So if you just want to use not the image collection itself, but actual software that allows these images to be exposed. So you have some other image collection that you want to use it on. That software is developed in open source manner. It's on Bitbucket, all the code. So you can, obviously copy it and run it in your cases. If you want access to the specific images, then you have to go through the proper channel. The reason that we have to go through this is because the image collection includes donors that their family members might, care about that information being kept private, and therefore the images themselves cannot be published on the public web.
And that's obviously very well understood. I think people will want to make sure that we are sensitive to that, and that there is a distinction between the professionals who need to access the data and the general public. And now, of course, we have a web page devoted to each of the podcasts. And so people who are interested in any of those links to Bitbucket or how to contact Donnie Stedman, will make sure that that's available from the web page that houses this particular podcast for people to follow up on. One of the things, of course, is trying to facilitate a variety of research studies through the platform, including ones that maybe you don't even necessarily kind of predict. I mean, it's interesting to think about all the different ways that you might be able to look at this data. Have you all been able to facilitate any research studies? Or are you anticipating particular pieces of research that are going to be leveraging the cloud platform?
Yes, so we're looking at the user study was kind of initial attempt to do these kinds of very kind of lightweight, short-term research studies. But right now we're involved in trying to actually conduct real forensic study, in particular trying to understand the conditions that are conducive to mummification. And there's some challenges there, even though we do have, for example, the weather information associated with each particular image. We really additional work on sampling strategies, because the images that we have tagged are not necessarily a random representation of the images. So if we see some association of, say, mummification with weather patterns, that might simply be spurious. We need to sort of kind of figure out ways to do that a little bit better. We're sort of in the process of doing this study. We hope to have more studies of this kind, and maybe this first one will give us some guidance on how to suggest other people proceed in these kinds of situations.
And as I kind of alluded to up front, there's some excellent research in the area, in terms of not only post-mortem interval, but as you mentioned, other post-mortem effects and how that tells you information about the decedent. But most of those studies are based on a very small number of individuals. Just by nature, the research kind of does not lend itself to high numbers of cases. So I think it's really kind of a useful tool here in terms of validation of a lot of the research work. I hope that a lot of researchers will take a look at this data set and say, okay, my 3 or 4 cadaver study indicated this particular kind of effect by looking at hundreds of cadavers across a wider variety of data. I might be able to validate or understand what the variabilities are in my results. I think in some respects that might be the most valuable thing, at least in the near term, that can come out of the work that you're doing.
Yeah, so I have a specific scenario in mind. So, for example, with this, one of the challenges I mentioned, we only have very small fraction of images tagged, right? And if you're looking for specific features, you want to see more of them tagged. So, from that perspective, with one of the useful features would be to add machine learning to help. So, perhaps instead of randomly choosing one out of 900,000 images to look for the feature they're interested, whether it be mummification or something else, and tag, additionally, we'll use this algorithm that would narrow it down and maybe give you 1,000 images where it's very highly likely to occur. So you can actually, even though it's not 100% accurate, at least it reduces the effort needed to conduct these studies tremendously. So that's one of the immediate thoughts that I had in terms of how to sort of incorporate not just the software itself of browsing ability, but also how to incorporate some of the machine learning techniques and understand that they may not be very accurate, but they could help in narrowing down the validation effort substantially for researchers trying to sort of capture much larger collection of cases.
Yeah, that's great. I mean, we're giving folks an early warning on a piece of research and a new tool that my guess is going to be a routine tool in casework in coming years. I don't know, maybe in a year, maybe in 5 years, but I expect that this is going to be something where every practitioner doing work in the post-mortem is going to be very interested in being able to access this tool and use it on a routine basis. It's really exciting to kind of see it in its infancy as you're building it and hear kind of the background of kind of your thinking about it and the ambitions that are sitting with us right now.
So my hope is that this study that we're going to do with law enforcement will give some ideas on what kind of scenarios they pursue. And so we can sort of adjust or add features that would be conducive for them. The example I gave is more of kind of focused more on researchers trying to find some, fundamental relationships. And I presume that law enforcement would have slightly different scenarios and maybe, will, as we do this user study, maybe we'll find ways to support them better in a way that this vision of everyone using it in their casework would actually be realized sooner rather than later.
That's fantastic. Well, I certainly appreciate the fact that you're willing to spend some time with us on Just Science today. I know that listeners are going to be really, really interested to download and listen to this particular material, and I certainly appreciate you taking the time out of your schedule to be with us today.
Thank you for having me.
And I want to thank you listeners out there for downloading Just Science. Please make sure to give us lots of likes and thumbs up on the podcast platform of your choice. And also tell your friends and colleagues about Just Science and all of the interesting forensic science research and development that's occurring. Thank you so much for being with us today.
Next week, Just Science interviews Dr. Igor Lednev about Raman microspectroscopy and advanced statistics for the detection and characterization of gunshot residue. Opinions or points of views expressed in this podcast represent a consensus of the authors and do not necessarily represent the official position or policies of its funding.